In question number 3, we're given two sides of a right triangle and asked to find one of the acute angles in that triangle. The acute angle we're supposed to find is labeled theta in each case here. Now, of course, if we were asked to find the third side, we would just be applying the Pythagorean theorem. But because we're asked to find the length of this angle, we're going to have to write an equation that involves either the sine, cosine, or tangent ratio, and then solve for theta itself. So let's start with the writing down of the equation. So let's look at part A. In part A, I'm going to again highlight where my angle is at. Here is angle theta. And you can see that in relationship to angle theta, I know the adjacent side, ADJ, is 17 units long, and I know the opposite side is 6 units long. So this equation is because it's opposite and adjacent, it's going to involve the tangent ratio. In fact, I can write down that the tangent of this angle theta is equal to 6 divided by 17. 6 over 17. Now, we are asked to find theta, and whenever we're asked to find one of these angles, right, what we need to do is we need the function that undoes the tangent function, which turns out being the inverse tangent function. So what I'm going to do to figure out what theta is, I'm going to apply the inverse tangent to both sides, and when I do that to the left-hand side, I get just theta, right? Because it undid the tangent. So now, after undoing tangent, I'm looking at just theta. And on the other side, right, I will write the inverse tangent of this ratio, 6 over 17, 6/17. So that's pretty straightforward to ask my calculator how to get that. You can see the inverse tangent function is on the same button as the tangent. You just need to press second to activate it. So here's the inverse tangent. It's the tangent that undoes the tangent. I'll just enter 6/17. And when I do that, it says that angle theta has to be 19.44. Now, this problem says round, what did it say? Round to the nearest tenth of a degree. So we're just going to go one decimal place. So I will write down 19.4 degrees. The answer 19.4, and my units are degrees. Perfect. Let's move on to part B. For part B, we're given, again, two sides, and we're asked to find one of the acute angles of that triangle. So I'm just going to highlight it again. And if I'm looking at theta there, you can see that I have the opposite, the length of the opposite side. So I'll write OPP. And the other thing that I have is the hypotenuse. It's the part that's right next to it. So I'll write HYP, hypotenuse. So we're looking at opposite and hypotenuse, and that would be our sine ratio, right? Sine is the length. The sine ratio is length of opposite over hypotenuse. So I can write down the equation now, right? The sine of this angle theta that we're trying to find is equal to opposite 77.9 divided by 101.8. And again, I'm just going to apply the inverse sine function to both sides. So I get that theta is the inverse sine of 77.9 divided by 101.8 degrees. So let's go ahead and evaluate that on our calculator. So I'll press second, inverse sine, and 77.9, and I'm going to divide by 101.8. And when I do that, I'm looking at an angle of 49.9 degrees. So theta is 49.9 degrees. And then finally, for example, or not example, for part C. In part C, again, we are given an acute angle. No, I'm sorry, we're given two sides of a right triangle, and we're asked to find one of the two acute angles. This is the angle that they want us to find. So again, I'm highlighting this angle. And in relationship to that angle, 17 is the adjacent side, ADJ. And of course, the 33 would always be the hypotenuse. It's the one angle that's across from the right angle. So I've got adjacent and hypotenuse. And when I see those two, I know I'm using the cosine ratio. So I will write down that the cosine of this angle that I'm trying to find, cosine of angle theta, is equal to adjacent, which is 17, divided by the hypotenuse, which is 33. So cosine of theta equals 7 over 13. Again, I'm going to apply the inverse cosine function to both sides. So on the left-hand side, it gives me theta. And on the right-hand side, I have the inverse cosine of 17/33. So let's quickly evaluate that. This is our final one for question 2. So second inverse cosine, 17 divided by 33, and 17/33. And when I do that, I get it is about 59.99. Now, I'm asked to round to the 1 decimal place, so look at that. Let's think about that. This is 58.99. So I'm asked to round to here. I looked at this and it has to kick it up. So this 9 is going to trigger this to become a 59, and then 0.0. Again, the 0 is indicating that this number really is rounded to the nearest tenth, and when we rounded to the tenth, that decimal did become a 0. So I'll write down 59.0 degrees. All right, so that's it for question number 3. Again, in question 3, we were given 2 sides of a right triangle, and we were asked to find one of the acute angles. And I guess now that we have one of the acute angles, it'd be pretty easy to find the other acute angle because they would both have to add up to 90 degrees. So that's just a thought.